Hi, Andrea here. We finally finished our introduction to the magic world of natural numbers. The theory is beautiful, but we are eager to know how this stuff can be relevant even in everyday situations. Therefore, today we are going to see an application of the induction principle. For example, let's assume we have an house with a front yard and we want to build a driveway made of tiles. Each tile has the shape of a square, and based on their dimension, we know that we need n tiles to reach the footpath. Now the problem. What if the tiles are arranged like a pyramid instead, with the side of each tile perfectly aligned with the next one after it? The question is, how many tiles do we need to build the driveway? The request is a general solution of the problem based on the number of tiles n required to go in a straight line. Let's visualize our situation. The best way to proceed is starting with a simple case and generalize afterward. So, let's pick n equals 1. Now, the total number of tiles is just 1. So, let's move to the case n equals 2. In this second scenario, we got a little pyramid. Let's move to the tiles to see if we can guess something. For instance, we can move the upper tile on the left. Then we put the right tile next to it. You see? It is a square. So, considering n equals 2, the solution is 4 total tiles. Okay, what if we move to n equals 3? Again, we can move the tiles in a similar way. And we got again a square. Here, counting the tiles, we get 9 as a result. Now, we notice that 4 is 2 times 2 and 9 is 3 times 3. So a possible general solution is n times n. This expression can be written as n squared. The name is not random, given that we end up with an actual square. Sweet! At this stage, it would be nice to have a compact formula to express the sum of the tiles in the pyramid. Let's write down how many tiles we have in each level. You can pause the video if you like, but we note that the number of tiles in each level is almost the double of the number corresponding to that level. Getting the correct number of tiles in each level is easy. It just takes to subtract 1 from 2n in every case. Therefore, to get the total number of tiles, we must sum the obtained numbers. In other words, the formula we were looking for is 1 plus 3 plus 5 up to 2n minus 1 is equal to the n squared found before. Guess what? We can use induction. It is clear that the formula is valid in the case n equals 1. In fact, the two sides of the formula are just equal to 1. So, let's see if it holds for n plus 1, in the case it holds for n. The formula in the case n plus 1 becomes as follows. The right term is the so-called square of a binomial. It is called in this way because it is the square of the sum of two numbers, and it can be written like this. It is a famous formula, so for now we take it for granted, but no one forbids you to prove it on your own. We can rewrite the right term using the square of a binomial. To conclude, the sum of all the numbers up to the second last term is the exact definition of our starting pyramid's formula, in the case with just n. Given that in our proof by induction we are assuming the case for n true at this point, we get an equality. In other words, the formula is proven and we finally know how many tiles we need for our house. I bet you did not expect so much math behind something so simple. That's why this stuff can be amazing. And you can do it as well.